Good afternoon, sir.
Good afternoon, ma'am.
Good afternoon, sir. Sir, Harsha sir just have joined us.
Good afternoon, ma'am. Good afternoon, sir. Thank you.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon. Good afternoon. Sorry, actually, I just late 5 minutes.
No issue, sir.
Can we start
Yes,
session now,
yes.
sir?
Yeah, please.
Yes, sir. I welcome expert of the session, Professor S.P. Harsha. We were blessed by him yesterday also, and it is again matter of pleasure for me to introduce him with the participants who were not in the inaugural. So, sir did postdoc from USA. Uh, PhD from BITS Pilani, BE and ME from MBM Jodhpur. Professor has been awarded 7 times for Best Paper Award in various international conferences. Sir worked and working in 3 international collaboration projects, 19 government funded and 4 private funded projects. Professor supervised 25 PhDs and having more than 100 research publications in reputed international journals. His research interest includes machine learning, soft computing method, dynamics of FGM structures, and carbon nanotube based on mass sensors, condition monitoring and high-speed machines, rail vehicle dynamics, and whole body vibration. I again welcome you, sir, and I request to share your wisdom with us.
Thank you, Professor Indu, and thank you, Professor As Rathorji. Thanks for inviting me actually for this wonderful topic and for this session. I'm really extremely sorry for the in the morning session. Actually, I just somehow missed out, and now again, I'm joining here. So let me share my screen. I think probably I'm audible to everyone.
Yes, sir.
I stopped my sharing my video because actually then there might be some bandwidth problem. So let me share my screen. This is no. Oh, where is it? Is actually let me. Uh, why it is not showing here? Window. Okay, yeah. So this is. I think probably my screen is visible to everyone.
Yes, sir.
Excellent. So again, let me start the session with this topic, design thinking, as the theme of this FDP is also on the design thinking. So since, as I mentioned yesterday also in my this inaugural lecture, that we are in the domain of some industry 4.0, where the people are now almost venturing into the automation. So then and there itself, you see the things come that what exactly the modification or the new exponential growth which is adopted by the technology could be applied to the machinery or the existing part of entire process, so that we can just go from creation to innovation. You might have, I think probably since yesterday and till today morning, you see here, you might have experienced about that the meaning of design thinking is neither about the art or science. It is mainly about the capability of thinking and to apply. Say you see here, like we people are now interfacing each other in such a way that whatever I am interacting, you are absolutely listening, and even whatever I am showing, you are getting. That's where somewhere you see here it was started way back, almost 5 decades before. That how we can using this part, not even physically we are present, but as it is as good as that we are interacting as on we are sitting on the either side of the table. So this is something which depends on the capacity and some kind of integrative thinking part. So, that was started even definition of design thinking. It was mainly started by, you see here, the Tim Brown, who defined precisely about this, that design thinking is neither art nor science nor religion. It's not about that some kind of existing concept which you apply and every time you can frame the things. Somewhere design thinking says that, okay, this is the existing part which we have. Now, how we can enhance not only the working capability or the process or some kind of refinement is requiring, but also it is basically a capacity. Ultimately, it is mainly giving us to see the final kind of design which has the integrative thinking. Integrative thinking is from conceptualization to final product, whatever the updation is requiring. Say you see here nowadays, as I'm many times I'm quoting, and this is by the way given by Tim Brown, and he said that this is basically a human-centered approach. Like previously, almost 30 years back or 3 decades back, you see here, we used to have a power plant by which one power plant having the same coal capacity, having the same water of thermal power plant, we used to produce 100 megawatt. We used to very happy that 100 megawatt and we have 4 units, 5 units. We were saying that, oh, this is a very, like the supercritical features are there and high power capacity. But now, even 20 years before or 2 decades before, view even the same capacity of, we can say, the workspace or the machinery, we were able to produce 250 megawatt. You see, 100 to 250. And last decade, we were, you see, capable and we used to produce almost 500 megawatt from the same plant by the same unit. And if we have 4 units, 2000 megawatt by the same coal, no change in coal structure, no change in water. We can't change, you see here. These are all the natural resources. But by putting, you see here, enhanced capacity and the integrative thinking, we were able to produce, and now we are into the supercritical zone where a single unit which used to produce 30 years back 100 megawatt, now it is producing 880 megawatt. How it is possible? Neither we can change the coal quality because it is obviously from the earth core, or it is the water, which we cannot change the water capacity that it can retain or it can produce the same huge amount of heat with that. That means somewhere the entire process, the materials, and the kind of design was so changed. So it was basically, you see here, this is a perfect example that even with the same resources existing part, we are now in a position to generate 880 megawatt by single unit of power, you see here, from the same part. Similarly, you see here about the same trains. Now we have the high-speed trains of the capacity of 200 right now in India, kilometer per hour, or in abroad 400 kilometer per hour. You see such a huge capacity, not only about the load to pair ratio, load to pair ratio basically, or else even the high-speed operation. So in another, like the definition which he refined, Professor Tim Brown, he said that design thinking is a human-centered approach towards the innovation that draws from the designer toolkit. So now it all depends on the designer toolkit. Designer toolkit is basically defined by the entire resources available in terms of designers thinking, and that requires to be integrated as per the requirement or as per the desired output. So for requiring that and to approach, you see here, towards that, we do need, you see here, the technology. That's where you see here, we were initially started from 100 megawatt and we are now approaching to 880 megawatt with the same kind of natural resources and the existing part. Only there is a change in technology. The material processing, the turbo generator unit, the blade, the entire processing feature from high pressure turbines to intermediate to low pressure turbine. The entire test rig of the turbine is so designed that with the same amount of, you see, we are not changing any internal heat, any enthalpy of the water, only we are changing the entire process that can handle to generate 880 megawatt. So that's where you see here, the business success is nothing but, you see here, to optimize the profit with the same constrained condition. So the constrained conditions are same, like we have the same coal, we have the water, we have all the processes same. There is no change in the process, but there is a modification in each and every part of the entire test rig, of the entire machinery and the material itself. So somewhere you see here, when we people are like going for designing of that, the first thing comes, you see here, is this. Look at that part. Background, the popularized, basically this design thinking is popularized by Tim Brown, as I mentioned previously, and also somewhere the David Calle of IDEO and some Stanford's school, basically business school, who simply derived that we need to rethink. There is always a requirement of rethinking of that particular part, where the design thinking can be applied in terms of creation. So in that, there is a structured creative problem. That is first. Now we need to devise a mechanism through which a structured feature could be evolved. And in this way, whenever you see the problem formulation is starting from the scratch, where we need to draw the things that how these basically the initial part, in terms of, we can say, the joints, in terms of the links, and using all the degrees of freedom, how a mechanism could be evolved, and in the mechanism, whether that can sustain the operating condition, whether it can sustain the boundary condition, and then during the process, how the entire problem can be solved. Now the problem is, again, important part is, the problem is to be defined very clearly in terms of more degrees of freedom, which can facilitate the realistic situation. The meaning is very simple, that whenever we are designing any or whenever we are trying to create certain thing, it has, you see here, the two main part. One is the non-uniform part, and one is the non-linear. So we know that whenever we are going for non-uniform or any non-linear system, which is actually the realistic part, how we can solve these processes, which has so much complexity in itself. So in that way, first part comes that, you see, whenever we are going for an innovation part, or whether we are just thinking that it can create, like using these processes, we need to maintain a structured feature to resolve these complexities issues which are there. Always remember, this is a thumb rule, that whenever we are designing any system which
Excuse
can,
me, sir.
yes,
Sorry for interruption. The
yes,
slide is
yes.
not changing, sir.
Oh my goodness, और मैं इतनी देर से लिख रहा हूँ, ये चेंज नहीं हो रहा है.
हाँ नहीं सर.
Oh my goodness, ओहो, मैंने तो काफी चीजें लिख रहा था. Oh, sorry, this is something. No problem. Present slide. Anyway, this is actually these slides. So, view, I think. Let me see. Reading view. Now?
Yes, sir. Now it is changing, sir.
Okay, so then now I can't write actually. This is really a problem of this Google. Actually, that it's not allowing me to now write or draw anything here. That's a real problem with this platform. Anyway, this is also so. Anyway, just I was drawing certain things. Anyway, so I was here. This is this part which I discussed already. I started from this part, and then I was discussing this. And here now, in this case, let me now keep this as. Oh, this is also not allowing me. Anyway, no problem. So I thought maybe it will allow me to go into that. Anyway, so this is here, that whenever we are trying to solve a creative structured problem, then we need to first see that what exactly you see here, the kind of feature to be involved in getting a desired output. So what I mean to say in this case, that the innovation or any kind of positive impact which we are basically looking, the first part comes here, that how we can create a structured problem which can be a compatible feature, or which can have a compatible features with reference to a realistic part. Because always remember, whenever we are going for a realistic situation problem, then it has, you see here, lots of complexity. And these complexity generally in mechanical processes, we are generally characterizing using non-uniformness, non-linearity, various things are there which cannot be effectively controlled or monitored together. So in this case, you see here, as it is rightly mentioned by, as I, like the Tim Brown, that the design thinking is a human-centered approach towards the innovation. So human-centered design process is there, and from there, like we are trying to inculcate, or we are trying to evolve using the designer's toolkit. So that's where you see here the designer's toolkit is not only enables us to like go for a freedom kind of, you see, the concept application or anything, but also it gives us, you see here, that there is a need to integrate all kinds of requirement, constraint condition, operating condition, and whatever the boundary conditions are. So that's where you see here the possibilities of this technology is to be evolved using the human-centered design process. So in this case, it is truly understand and empathize with the kind of user. So we have, you see, the first part is the empathize, and in this case, basically, we are trying to go for an iterative process. So in this case, whenever we are trying to go for some kind of the iterative process, it gives us that what is the people's need. So whenever we are going for empathization, actually somewhere we are trying to include whatever the requirements are there. Those requirements, or we can say in general, like in the business model, we are saying it's a customer requirement. These are one of the critical pillar for that. Once we acquire all these requirements, then we need to define this definition. Actually, I can't use the pen. So this definition is mainly having a structured creative feature. So in first pillar, you see here, whenever we are going to evolve this, somewhere we need to see that how these, we can say the definition of problem through which we can define all the processes to get our, we can say, all the requirement of the people, or requirement of, you see, the desired, we can say the human centric feature, that can be coupled together. And then you see here the other part, since it is an iterative process, so now we need to ideate, means we need to conceptualize, we need to go for prototype part, and then the experimentation or the testing features are there. So somewhere in the design thinking, right from the scratch, that what exactly you see the inputs which are mainly there from the variability. Remember, you see here in this part where the people needs are being considered, we need to be very clear about that how much uncertainty is involved. This is the first pillar. Second pillar in this case, which we are generally including, is how we can collaborate these part. Because that's where the things are. Because if any idea which is to be floated, we need to first see that how compatible these ideas and the people needs are to be integrated or collaborated in that part. So again, you see here this cycle which you can see right from like the empathize to testing part is basically a iterative process, and we need to iterate, you see here, in that way, so that we can refine, we can go for appropriate accuracy, and the desired precision can be adopted in that. So all in all, you see, if you look at, you see, the definition, design thinking is essentially taking analytic. So somewhere you see the computational aspect. Analytic is always, again, you see here, though it is a computational model feature, but it relates empirically that this is the input and this is output with this much correction factor. The analytical features are always giving you an exact configurational changes within the system design. So this, please be remember. So whenever we are initially starting from that, we have to be very clear. Like say, you see, I want to design, one aspect of this. And I know that if you look at, you see here, that all the iteration, we have some kind of complexity. We need to define that complexity. Say example, very common example, which we are using. all these processes in our thermodynamics, like isochoric process, isentropic process, you know that these processes cannot be happen in realistic way because there is a entropy. There is always some kind of disorderness. Any process which happens, ideally it cannot be happen. But whenever we are analyzing those things, we are making the exact relation between one property variation to another property variation, stating that it is applicable to an infinitesimal element. Means that this can be happened only if we are using a very small element, no dimension, but that element itself facilitate the linearity in between one property variation to another property variation. So this is called the analytic part. Second is reflective. Now, since we are trying to derive certain things, say I'm applying a force, certain you see on other side F equals to ma, that mass is now accelerating. So that means there is a reflection. When I apply the force P, we know that that area is under force concentration or some intensity of the force is there. Any example you see here. Okay, so that means you see here, once we are putting, you see the exact relation, there must be a reflective phenomena in those components where the active part or where the driving force or anything which is to be applied there. And finally, it's a critical thinking which enables, you see here, that this is these are the typical zones. If you look at, you see on right hand side, there are some red zones, there are some gray zones. So these red zones are indicating something. That means, you see here, there is some critical thinking is requiring at certain sections, because we know that there is a non-uniformity, though we are going for a very small infinitesimal element. But during this iterative process of design thinking, we need to remove those clots and putting it all together. So that's where you see this is the tactical domain of design thinking, where we need to apply, we need to critically resolve those conflict conditions, which generally we used to say that it is a constraint condition by an iterative process. So design thinking is an iterative process in which our main requirement, which we seek to understand the user. That's where you see here the empathy, where the people needs were there. Second part is challenge assumptions. That's where it is. As I was mentioning about that, you see here, we are simply putting certain assumptions to resolve initially. But when it comes to in a reality, in an overall way, we need to now challenge those constraint conditions called the assumptions. So if we feel that during the iterative process, we cannot resolve all the processes, then we need to resolve one by one, like losing our iteration or the nodes in that. And then we need to redefine the problem. So under various circumstances, we know that all the design cannot be approved or achieved as per the required one. But how many we can do? We were trying to do that, and then we need to rethink. We need to redesign the other processes by adopting a different kind of assumptions. So in an attempt to do those things, you see here, we need to identify the alternate strategies, which I was talking all about, and all those alternate solutions that might not be instantly apparent to all that localized problem, but at least it is giving us the initial level of understanding that these are some easy, linear, and like we can say straightforward issues, and these are some complex issues which are requiring to be resolved by adopting a different methodology or different design process. So this is where you see, in the iterative process, we need to challenge ourselves and our analysis by putting various initial assumptions and release those assumptions by defining or redefining or modifying those conditions there itself. And that's why you see here now, even today, as I am saying that, you see here, we are able to produce 880 megawatt power by that unit. But this is not the final part. Maybe tomorrow, after 5 years or decade, we have a new material that can sustain the huge amount of temperature and all that kind of inertial forces. Might be you see the 1000 megawatt by the same unit. See, starting from 100 megawatt when it was designed, you see, and now we are ending up to, maybe we don't know, maybe more than 1000 megawatt. So in that iterative process, you see here somewhere the various things are redesigned in such a way that it can sustain that particular part. So these solutions were not instantly, it was a iterative part. So it used to now iterate in that particular manner. So like when we are thinking about a designing process, design thinking provides a solution based approach to solving a problem, because it is a human centric part, as it was defined by the Tim Brown. So in that, all the innovations which were drawing from the designer toolkit, so certainly now the solution based approach could be adopted using those toolkit through which we can integrate the needs of people. That was, you see here, the main part was there in our empathize. So that is the first pillar of this. So it is a way of thinking and working, as well as you see collection of hands onto the method. That means, you see here, we are trying to refine various things towards that. So here, this is the sweet spot of the innovation, where you see the creation starts right from the three main part. One, again remember, is the desirability. So desirability is basically putting our creation, that this is what you see, I want to evolve this process. And in this way, because you see here the needs are coming from that, and we are generally keeping this in an empathization of the people need, then we are putting, you see, the feasibility. The feasibility is basically a feasible solution, which you might have discussed or understand from our optimization, that there must be a feasible solution using all the constraint condition and the defined objective function. So desirability is mainly coming in our objective function constrained by all these conditions as per the people's need, and then we need to get the feasible solution. So sometimes these feasible solutions are computationally or analytically okay, but when we are going to apply towards the test condition after prototype, you see here, because the idea, we can simply conceptualize those things, but when we are going to the test position, you see here, there are somewhat, we can say, complex conditions are there. So we need to now see that how those assumptions can be resolved, you see here, during the testing time. So in this way, you see here, the viability comes. That you see here, though we have the solution, now whether this solution, the whatever we have, you see, the solution is sustainable in that way that it gives us, you see, a kind of targeted profit. So these are basically, you see, the sweet spot for that right from desirability to go towards, you see, the feasibility or the compatibility of the situation, and then looking at the viability part to enhance, you see, the things. That is most important part towards that. So guys, you see here, when we people are talking about design thinking, these are the critical steps to be discussed and to be see first prior to go. We cannot think that I can simply touch to the sky. That is not feasible. But if I can simply put certain processes through which at least I can see some kind of height using my unmanned air vehicle, using unmanned surface vehicle in the sea, or wherever it is you see here, if that can be done, there must be a feasible solution towards the desirability of that. So here, if we are introducing this part, design is a process basically encourages participant to think outside of the box. This is what it is. As far as you see here, the critical design is concerned, generally, we all know that whenever we are designing, we are always thinking first that what exactly the cross-sectional features are, what exactly the materials is there, how much load it can sustain. If it is not able to execute those things, then what exactly the correction factors are there, what is the factor of safety is there, under static, quasi-static, dynamic loading, what the things are there. So, all these processes, which used to, we are applying there, we know that there are always some kind of constraint. But to resolve those constraints is the thinking outside of the conducive box. And that is mainly, we can say, a pursuit of creativity. Somewhere we need to create not only about the process refinement, but also we need to give the innovative solution. So, like people are now talking all about, you see, the startups. Startups is what? Now, we are trying to facilitate a certain thing using a different, we can say, tool from the toolkits, or using some kind of, you see here, the facilitating feature. So that feature is coming out from, you see, a creative or some kind of innovative solution. But it should have a compatible to your mobile. It should have a compatible feature in entire process of the transferring, whether it is money, whether it is anything you see here in that way. So today, when we people are in the virtual domain, this design thinking is really providing a domain where we can think beyond, you see, a conventional box, or beyond beyond we can think the conventional processes for that. So for this, it is we can say design thinking proposes a get your hands dirty. That means somewhere you see here, this is a very well said that you see here that we are almost crossing the safer approach. It may be, we can say we may fail, so we may get, you see, our hands dirty, but there is a great chance of learning by doing approach. So that's where you see here, we are not supposed to confine ourselves within the safer design. We need to cross that particular barrier, and that generally we are saying that this is the, to get your hands dirty. So successful businessmen are making billions by recognizing the value of integrating design thinking into their process, and this process is a localized process. Again, the localized process means even it's a very well set process is there. We can simply go and do the things, but at each and every part of that entire process, they are now simply modifying or refining using their own toolkit. And that's where you see the human centered part is. So, this is what the things are. So, design thinking shifts the focus from a business centric engineering solution to a customer centric. And that's where you see the business centric is the global solution, and that global solution could be anything in terms of a generalized solution. But we want, you see here, that each and every part of the people's need must be addressed and resolved. So, somewhere it is a customer centric solution is requiring. So in the empathization, you see here, our main approach is to resolve this human-centered feature, which were there, if you remember, you see here in the definition of Tim Brown. And that's where you see here, we are trying to integrate all the needs of problem and trying to resolve using designer's toolkit. So that's why you see, this design thinking is giving you an overall approach starting from a localized solution of a small problem, starting from people's need. So when we people are talking about the design thinking, the first thing comes about the pillars of design thinking. So in the pillars, you see here, if you look at that, the first part which I am continuously saying is to emphasize those things. So emphasize the people need. We need to upgrade. We need to integrate that part in this. So excuse me. So we are trying to integrate, you see, the people's need in the first pillar called empathize. So once we empathize this part, then second part is coming as the collaboration. So in this way, you see here, we are trying to collaborate the various features to make the thing successful, starting from the disciplines. That means you see here what exactly the different kind of processes, what different kind of the technological features are involving in getting the people's need. What I mean to say in this, sometimes we need to upgrade. You see here that, okay, I want to design this. In the design, there are some mechanical input, there are some thermal input, there are some electrical input, there are some radiation, various things are there. So whenever I'm designing that part, somewhere I need to collaborate all those kinds of concepts to facilitate what my object requiring to fulfill the people's need. Second is the skill set. Skill set is nowadays we people are talking about that if the material itself is smart enough. So we may have, you see, the smart materials, or the process is smart enough. How the process could be smart enough? By putting the sensors and appropriate actuators. So that's where you see here now, the sensors are sensing all these environmental conditions. There is a dead machine, there is a dead object, mechanical machine, but it is interfacing with the surroundings using sensors like human skin. Now, in the human part, you might, if I'm asking you now, tell me what is the temperature, your skin will immediately say that this is the temperature because your skin is good enough to sense that. Or if I'm speaking something, you people are listening. So your ear is capable of getting what I am saying. So there are various sensors. If I'm asking you to taste that. So the testing part is there by your tongue. If I'm asking you to see those things, so your eyes are there. So these are the sensors of the human part. Similarly for the machine, when we are trying to set the skills, we are trying to integrate the sensor and appropriate actuator for an appropriate mechanical motion at the output. So that's where you see here, when we are trying to calibrate this, not only you see here all the disciplines which are there, like within that particular component design, also we are trying to set some skills within the system itself. And once we do that, because these are not only you see providing, the sensors are not only providing the monitoring, but also it gives us a kind of measurement about the sensing feature of that particular machinery. And then the perspective parts are there, that when we integrate that, what exactly the kind of output which we can expect after integrating based on the people's need. Then include every idea invisible from the like in form of evaluation and in form of the iterative feature. So once we fit that, okay, now we evaluated and it is not up to that mark, as you might be knowing about the feedback control system or any kind of control system. Once we because we are monitoring here, we are trying to set our skills by adopting the new technology. Okay, so even in, if you look at that, you see now people, when we are going for manufacture, like the maintenance part, the condition based maintenances are there. Like in that way, we are all trying to integrate for a appropriate health monitoring. Integration of all the sensors and actuators are like providing a kind of feasibility to evolve that. Finally, you see the repeat, iterating, and testing solution, because after evaluation, if it is not up to that level, we need to we need to upgrade the system in that way. So the testing, after you see the prototype, when we are going in the testing, we are trying to put, you see, in the closed loop form solution, that this is what the human needs and we are trying to achieve up to that point. That's where I was mentioning that, you see here, the 880 megawatt in power production is not good enough. Today, it seems that, okay, we have almost adopted, you see, the supercritical features. But these supercritical features are stopping here. It's a doubtful part. We may cross, you see, the 1000 megawatt. So human needs are changing. And with this particular change, the entire pillar, right from empathize to collaboration to include every feasible and the, we can say, the viable solution to be integrated using iterative process can be changed and can be adopted like that. So this is one part. So when we are trying to see the pillars, our main process comes in the steps in the part. So there are, you see, the part which I was, indicating earlier, that, its first part is the empathize. That means to create a meaningful innovation as the need of the peoples are coming. So these are basically the input part. Once we have, you see, the input part in terms of the range, in terms of, you see, that what exactly the total limits are there of the parametric variation, that this is what I need. Like, you see, I want to design a car and that car must be there on the battery. So now you see, I have two inputs critically, that I need to design a four-wheeler, and in that I need to use the battery. So the entire engine and power transmission system will be different. So this is what the need is. And in this need now, what is the capacity of the car? That means, you see here, what is the total power which is required to be produced by those batteries? So once we started in that way, we need to think that that this is the power capacity, and this is what, you see, the sustainability, that by charging once of all these, maybe I need 4 batteries, I need 10 batteries together there, and it can move up to, we can say, 200 kilometer, 400 kilometer, if it speeds up to 50 kilometer per hour. If you exceed the speed, if it is first of all feasible, so the feasible solution comes here. So once we, create a meaningful innovation as per the need of the customer or the people's need in the empathize, we need to now define. That's where you see the things are coming, that the optimization function is to be defined based on that this is the desired one part and these are the feasible conditions towards that. Because we cannot iterate, you see, n number of times using our, we can say, excessive optimization function. So the definition is a framing of right problem. Right problem here means that you see here that should be visible within that. So whatever we are creating the problem, it should have a structured way so that we can get appropriate solution using or like enabling the innovation and positive impact. That's where we discussed about that. Okay, so this is one. So once we define the problem, again, you see here, the question comes, what do you mean by right solution? The right solution is a feasible solution because you see, if you remember, there were three things: desirability, feasibility, and viability. So feasible solution is one which can put, you see here, in the right solution, but it should be viable. So if I'm appropriately giving you a definition of right solution, means it should be feasible based on, you see, whatever the strength of the operational capabilities, but also it should be viable to provide some kind of profitable solution in that. This is one. Second, ideate. Now you see here, like ideate is not about coming up with the right idea. It is about generating the broadcast range of possibility, because we all know that, as I was discussing right from beginning, that the real processes have a complexities. So when we have the complexities, how we can resolve these complexity? Because the right idea is always a linearity. There is no complexity. But if you are not crossing that particular black box which has confined boundaries, so if your thinking is not beyond that particular, we can say, box, or if we are not able to get our hands dirty, then we cannot get the broader range of possibilities of the solution. So ideate says that now cross those barriers and get some idea. It might not be right one, but at least it is exploring, you see here, in such a way that we can get some different kind of ideas from that. So this is one. So like right from emphasize to define the problem, then ideate to initiate that, and then we are building, you see here, a prototype part. The prototype part is always giving us that whatever we are conceptualization right from beginning, can it be done at a lower way, at the scaled one? This is a very common engineering practice which we are generally adopting, that we apply all the conditions at the lower scale part and see that what feasibility features are. Because like here there is, that might not be the viability part, but there is a feasibility that okay, it is responding against those conditions in that manner. Once we get that, then the real testing is coming to get an appropriate solution having both feasibility, desirability as the optimization function, and you see here the kind of viability towards that. So these are basically the steps, and if you look at that, the steps are, like though they are basically being connected to each other right from empathize to testing part, but it has lots of flexibility at each level. So at the localized level, we can simply modify, we can upgrade, you see here, the entire process towards that. So this is where you see here the initial starting part, that now when we are starting from this part, you see here, we need to now see, first discover that what exactly it is, what is exactly, you see, in the empathize problem, you see here, what is the need and how we can add those needs using more flexible processes. So here, if you look at, we have a diverse part. That means somewhere, you see here, it simply gives us the nature of problem can have a feasible solution or can have, you see here, some kind of optimal solution. And if it is diverging means if we are not able to, like get an appropriate solution, now what are the controlled conditions there? So in this case, you see here, we are defining what are the parameters which we are generally monitoring using the sensor could be controlled to get a converged solution. A converged solution means a feasible solution for those problems. So if you look at, you see the first part here, it simply integrates two things. The discovered feature means what exactly our parametric variation, which has some kind of uncertainty, could be added in such a way in the defined part that we may have a feasible solution after putting the converged part of those parametric variation. Remember, you see here, the first diamond is simply gives us a precise definition of our problem, which indicates that it has a feasibility. So this is what the things are. Once we see the feasibility, now we are trying to develop. So in the developing part, there might be some kind of problems in uncertainty, or some kind of diverge issues are there in the options because of material, because of some geometrical changes, because of the process in which some kind of we can say abrupt changes are there. Lots of things are there. So during the development, there are various, like we can say vows are there where it requires some amount of control. And this control comes with appropriate technology. So that's where you see here, like the double diamond in this process, it simply says that once you define, and even we can get, you see, a absolute configuration, like you see here, if I'm thinking that okay, now in the design aspect there are certain critical issues which are not being resolved clearly at the conceptualization part, then in the process part it can have appropriate control, because of, you see here, when we are monitoring the parametric variation, we can simply keep those limit range or the tolerances in such a way that the solution can be converged. So not only from the conceptualization, but from the process itself, you see here, we can simply put the control. So that's why you see here, design thinking is another way of representation is the double diamond process model, where we can not only like control at the conceptualization part, but also it can be controlled at the process level. So when we are now, like defining this part, now the thinking of design, thinking about design, and thinking through design. This is a real, like though it's about the play of certain words, but these words are giving us a clear idea about that. So when we are talking about, like the thinking of design, that means now we are trying to imagine, or we are trying to understand that in the design what are basically appropriate practices could be adopted and where we can apply. Means, like you see, earlier we used to have a same we can say the IC engine, in which you see whether it is spark ignition, or we can say, like the compression ignition engines are there, the internal combustion. And say even in the car, it used to have a mileage of 20 kilometer, less than 10 kilometer per that. Now even we have the sports car, which has the mileage more than 30 kilometer per hour. Imagine, you see here, thinking of the design of that particular engine, which now not only speeds up, but also we have, you see, the refinement. So somewhere you see here, we are trying to see, we are trying to understand, or we are trying to develop some new methodology. Or in other way, let me explain, like explain the other thing is that earlier we used to have a power transmission from steering to, we can say, all rear and front wheel using mechanical devices. We have a gear train, we have, you see, the entire, we can say, rod and everything. But now entire mechanical process is being replaced by new mechatronic system evolving from sensors and actuators. These actuators are even the servo motors, small motors, and they are absolutely in that particular entire powertrain. See, no mechanical loss, no frictional features. Earlier we used to have different gears, gear trains, and all that kind of stuff. See, high speed, high power transmission, but no mechanical features involving directly. So somewhere you see here, when the people are going into that, somewhere, if you look at design of thinking is to imagine, to visualize, and to dream up the new understandings, where we can simply say that this design may have the new role, which can be applied directly to various applications. About thinking, because this is of the design thinking, now about thinking to consider, reflect, and deliberate the ways to study about the perception. That's where you see here the capability enhancement comes here. that how we can enhance, you see here, from the same. So here, design about thinking is giving you the new ways of adopting the materials and the processes that we can apply, you see here, these kind of material. And that's why you see here, nowadays, more and more research is there on the material side, so that we can reduce the inertial forces, the bulky materials are replaced, but at the same time, it provides the enough strength which is to be required there. And finally, design through, thinking through design is ability of certain principles to use those design methods and using that uncertainty and complexity. So since now we are into the fabrication or we are into the test or any kind of prototype part, through these design, now we need to adapt that part. So you see here, these are basically the three key parts, especially about the design of thinking, about thinking, and through thinking. We can simply, put these kind of skills towards that. So, this is what we already discussed about that design process in the thinking way, starting from empathy, and then we need to interpret that what are the people needs and how we can, put the skill set towards that. And once we do that, then how we can imagine, you see here, in the design of thinking part towards that. So in the entire process, you see here, somewhere we are trying to integrate those new innovation using the toolkits towards that by interpretation and imagination, and then we can plan accordingly, and testing is there. So this is the do loop, because as I already mentioned that it is an iterative process, so we need to iterate that part. In the same way, you see, for the education also, we need to understand the need of a learner. Then we need to highlight, you see here, of the, the gaps in the class and individual student somewhere. So either it is a global class problem or it is a local student problems here. We can simply highlight those things. Then accordingly, we can design our new lectures that here the student has some kind of communication problem. Student might have some kind of numerical because of the background is not that sound in numerical, or sometimes they may have some kind of physics understanding problem. So lots of things are there. So even you see here, we can simply integrate various things to upgrade those kind of issues which are mainly there with the individual or the class, and then it can be delivered. So again, this is a kind of, we can say, iterative process, and accordingly we can upgrade ourselves, you see here, with that. So since you see here, this is what you see in the design thinking part, there are various things to be integrated or in a collaborative manner. So we can simply show, you see here, using that right from empathy to define and to ideate, you see, and to prototype and test, you see here, all these part. So somewhere you see here, if you look at that, right from, you see here, this empathy to define, now we are trying to define a appropriate problem. So it requires the synthesization. Synthesization is nothing but starting from your basic drawing of that system to material aspect. We say, you see here, I just want that this is what my desire is. And if that cross section or if that material is not capable enough, so this synthesization is simply giving us an appropriate compatibility before defining a problem that this is what you see the people's need and we need to address that. Second, to define, to ideate, you see, once you define that, then to ideate those things, now it requires the Stokes various. So various Stokes are there through which we are trying to put those limits or the ranges where that can be ideated, that can be initiated. And once you do that, then we, prior to go for prototype, we need to select an appropriate processing for that. So somewhere you see here, and then once we adopted the prototype and we have simply at the scale down situation, we perform certain things. Now we need to show all the skill sets of that particular assembly or sub-assembly to go for the final testing. And then after iterating, we can go. So somewhere you see here, when we are trying to integrate all those, we can say, steps of innovation, somewhere you see the toolkit is giving us all kind of analysis from this. So this is where you see the things are where we are trying to go and see that how it can be performed. So wherever the performance comes, there are various, we can say, inputs are requiring. And in this way, you see here, this is where, like we can say, appropriate connections in between all that part. This is the same diagram, but only it has, you see here, some emphasize and then define, ideate, prototype, and test. And this is what we can say broader model which are simply giving us, you see, an appropriate global and the local solution as and when you see it require, we can go for some kind of corrections in between there. So this is a very important part you see here. So here, when we are going into that, if you look at that, there are three main, we can say a broader feature. One is to understand. So in the understanding part, you see here, these are the two categories to explore. Now, since now we are in the implementation zone, so we are exploring and to materialize that. That okay, now this is what happened, and then it is executing in this way. So accordingly, we can simply choose this part. So when we are going in this, in the emphasization, certainly you see here it requires a deep understanding of problems and realities of people which you are designing for. This is a very important and critical part there, that it is not only giving you a basic problem, but also it is giving us that what exactly the requirement, and it requires what kind of, we can say, the methodology or the process. So there are three steps which are mainly, we can say, putting the constraint conditions here. One is to observe, then to engage, and then to immerse in such a way that we can understand in appropriate way that what exactly the problems. It's not about the problems, it about, you see here, the desiredness to be designed, you see here, at this particular level. So once we design this, then you see here we are trying to, give the appropriate solution by defining the problem. So here you see here, when we are now designing, because more or less you see here we are somewhere in the design part. So when we are designing those things as a design part, just like you see here our mechanical design or any kind of design, there is a individual part that this is to be designed. These are the processes which can be adopted to design this part. This is the methodology, this what the outcome. So there is a definite individual, definite product is there, and some kind of engineering and some kind of geometrical features, the art is there. They are all rigid, based on some empirical relations, it is there. But now when we are simply adding the design thinking, then the things are almost different in the different domains. Now the domain which was very static in the design is now a dynamic domain. There are teams, because there are four pillars, as I was mentioning previously, that there were four pillars of that, and all these pillars, right from empathize to collaborate to, we can say, the evaluation of that, and then to iterate and testing part, it required different teams for that. These teams are integrating all those concepts, and then they are experiencing using the prototype and the testing, and then they are iterating. So in this case, as you see in the first slide, I was mentioning that design thinking is a human-centric approach. Basically they are using the innovation, to draw certain kind of, we can say, the designer's toolkit, and then they are drawing all sort of possibilities using technology. So human is a common domain in between the tech and the biz part. That means somewhere you see here we are trying to integrate those things there itself. So this is, you see, the design and design thinking. Then these are the different principles which we are generally because we know that until unless if we are not defining clear principles, certainly you see here the unimaginable thinkings are coming out. So first of all, this action, it is action oriented, which in which you see here the human centric approach is absolutely requiring. So since the human is in the center, so what kind of, you see, the desired outputs are there based on the empathy. So action feature is then support change. This is where you see the feasibility feature is coming, because we all know that here whenever we are going for appropriate solution in the innovation, we need to see the feasibility and the viability part. So these change must be supported by those design part. Say if I know that this 100 kilonewton load is coming, but if my support is not being there at the structure, or the structure is so much ruptured at that point, so certainly you see here, or if I just want that this much output is there and there is so much inefficient operations are being adopted, so that means you see the entire system is not acceptable or adaptable, you see, of those changes. Focuses on human is basically the skill set. So we need to set all that part. So if you look at, you see, right from first to end, somewhere we need to combine two things. the logical way of doing certain thing, and the creativity. So it's not that you see here we are adopting those processes which are not feasible with those materials. Say if I'm using, you see here the plastic, and if I'm asking to do all those processes which are only applicable to metal, then certainly there is a failure. So somewhere we need to adapt. That's why I am saying the feasibility is the must domain, and then viability is the on top of that. Then only we can go for, you see here, a absolute we can say the process of the design process, the design thinking part. Sorry. So here now we have the various things in this. One, it is non-denominal. That means you see here the sole domain of designer or design manager is basically to focus on what is the desirability. Then we need to align that. So somewhere you see here we need to align the entire part. It's not that you see here if designer says that I can design, and the entire process team at the manufacturing part or in the process where the maintenance design team says that that is not feasible. So that means somewhere you see here we cannot optimize those feasible solution within that. So, like even if you are going for creativity, agility, or efficacy, you see here, it has to have a balancing act towards that. Okay, so that means, like whenever we are trying to go for this, we need to set all those conditions at the, we can say, equilibrium manner, so that it can be in a proper collaborative manner, and all the toolkit which is there within the innovator, you see here, it can be applied to every stage. Then we have means to deliver creativity. Obviously, you see here, like our main is the customer centric part, which I was defining like initially, that whenever we are basically going for customer centric, then certainly you see here, it's not about the business centric engineering solution. This is a customer centric. So we need to now deliver certain thing, that what exactly the kind of viability features are there in that. Then we have, you see, the exponential and the predictive mechanisms that can be added to this. So these are basically, you see, the processes. Then this is another part you see here, which we already discussed, and we are generally saying that whenever we are trying to frame all these processes, we need to see that how much, you see here, the maximum uncertainty can be handled during part. And once we put that range of uncertainty here, if you look at the blue part, then we need to reframe, we need to recreate, you see, the solution to converge that. So please remember, you see here, any emphasized problem is always being associated to rephrase or to an iterative feature to convert that. That's what you see we discussed already. And then even in the ideate form, whenever we are going from that point to prototype one, you see here, somewhere we need to see that it's, like whatever the right idea in the ideate part, which are mainly coming, it has to have a broad range of possibility to convert this idea into a appropriate prototype or the testing one. This is an essential part there, you see here. So either it is a problem space or in this solution space, somewhere we need to clearly define that how these challenges which are there, you see here, can be handled at a conceptualization state to, we can say, the final solution state. So you see the design challenges which are basically being resolved at every stage. Please remember, this is a very local solution problem, gives us a feasible situation, right from conceptualization to final execution of that. So when we are doing this part, you see here, we need to, it looks like, you see, it's a very straight one. That, okay, now we can resolve all these clots, all these nodes, all these constraint conditions, and we can get an appropriate optimal solution. This is not like that. This is something like this. And that's why you see here, if it is as straight like this one, then you see here it's a very feasible solution straight away right from beginning, and we don't need to go for iteration. But it has a complexity, it has an uncertainty feature. So somewhere you see here, we need to resolve these issues together, you see here, by various processes adopted. And that's why you see here, there are various concepts. If it is so straightforward, you see here, then we can go by the same definition and we can resolve that. It's not there, you see, a straightforward issue. Then somewhere we need to resolve these issues using a different, we can say, different approaches from that. So what are the approaches? So it indicates about the branding of that. So when we are going into the branding, this is what you see the design thinker group. So in the design thinker group first, they said that it's a very straightforward thing. You look at like that. We have, you see here at the first problem space and the solution space, there are only the integration of diverge and converge by emphasize and reframing, ideate and prototype is giving me on diverge and converge conditions. So this is one part. So this is very standard, we can say thumb rule, but many times it creates lots of uncertainty in any of that. So then they say that no, we need to add certain thing in this way by Stanford Deal School. They said that emphasize and instead of reframing, you first define that. So as far as you see, like we discussed about the define means we need to frame a appropriate, not the right problem, but appropriate problem in such a way that we can create the right solution. So it doesn't require then reframing. So we need to at the problem state we can create our, and then we are going towards the ideate, in which you see here, like we can just simply go for the broadest range of possibilities of the idea, and then prototype and testing. So somewhere you see here, it is a minor modification in these two parts. But when we are going for IDEO part, where you see we need to gather the information, we need to generate that part, we need to frame, and then we need to share. So somewhere they said that, okay, since, and then even some minor modification in that, in which you see here, it is more of some kind of visualization, more of some kind of, we can say, creation. So an inspiration to ideation and then implementation. So if you look at, you see here, right from beginning to end, you will find that somewhere you see here, the data collection, or to, we can say, the creation of some meaningful innovation, it requires some kind of existing part, whether it is coming from the users, whether it is coming from the demand, or whether it is demand means, like the customer demand, or whether you see here, the things which are being observing or looking at certain things through which we can inspire ourselves and we can simply create, because it's a human centric feature. So all these initial part, whether it is basically coming out from the need of people, or whether the conditions or anything you see here, they are mainly giving us various kind of parts. So this is the branding part you see here. And in this case, you see here, we can simply go for the various methods and tools. So here, this is, like when we are going for the methods and tools, you can see right from beginning that here in the first stage, where we were there basically for our problem space configuration, we have design changes, challenges. So this is one. Second, the stakeholder mapping. These are coming from the other side, or we can say the context mapping there itself. So all these, if you look at that, you will find that there are, you see here, the various methods and tool which can be adopted at the local level to refine and to go for the iterative part. And these iterative feature, which is mainly coming, is basically providing us, you see here, the customer centric solution. So that's why you see here, we are trying to shift our focus there, like from business centric to customer centric by adopting the various modification at the local level, at, we can say, like right from our problem space to the solution space there itself. So this is one, and then we can simply go for a perspective feature of that, that this is how you see the things are being integrated appropriately, and then we can simply go in this. That means you see here, this iteration, in which the reframing is there in one way, or in other way, you see here, we have some kind of defined features. This is only this part. The main part is this, that how much variation can be accommodated at the emphasized level, and then to ideate, and mainly we are going for this prototype and testing. So somewhere you see here, it is not an ideal this part at the problem and the solution space. This is actually about this. So if we change our perspective feature towards that, then we can get an appropriate solution for this part. So this is broadly speaking about, you see, like that part. And then we can also, like go for some kind of creative thinking process. This is what the last slide, which is like this, that, like this is all, like the bigger ones are there. So here, this is something, like about the creative thinking process that we have, you see, right from this, in which various, we can say, the stages are there, right from, right from inspiration two vision, two idea basically you see here. And in that you see the brainstorm features are there that we are basically going for, you see the various kind of training and the iterative feature. Then on the other side, these are basically our toolkit from where the innovation features are being evolving and we are trying to apply. So this all comes through our basic features that you see how we can define, you see the problem, how we can gather, you see lots of information and then we can apply. So nowadays you might have learned about, you see the various machine learning, data learning, reinforced learning features. They are nothing but you see here through the existing data, we are trying to train ourselves and then we are applying, you see here towards the other side. So this is somewhere you see the integration of all those existing design and to apply for a new challenges part in that way. So these are all the technical terms. And then you see here, whenever we are going for engineering design process, this is where you see the things which are mainly being adopted. The problem definition, information gathering about the data, about you see the material characterization, everything. And then we are basically going for conceptualization. So in the conceptualization, you see again at local and overall part, you see here we are trying to conceptualize, you see, and then we are evaluating all the performances, and then we are going for the entire features in the product development, right from detailed design, parametric design with the variation in the tolerance and all, configuration design, and the architecture of product. So this is there, and all these slides basically behind that is somewhere close to that only, that you see here how we can design that and what exactly the kind of complexities are there, the type of leaderships are there, two types of leaderships which are mainly there, and it has basically the four main, we can say the characterization, rather idealization of influence, inspirational modification, this motivation, we have individual consideration in that part, and finally we can go for the intellectual stimulation. So simply you see here when we are framing the team, then obviously it all totally depends on the leader, that how you see here all the different processes could be coupled and a smooth flow is there right from the conceptualization to material. In this way you see here we can even go for that how we can reduce this particular feature that we have, you see here in the design part. Earlier we used to have lots of complexity in the mouse. Now we are simplifying. So simplicity is another key part of design process. Like you see previously, this was, you see the big part. Now within this module, you see here, we have all the spaces. So this was the space of megabyte. Now it has a space of terabytes and beyond that. Similarly, we can go for the of our wheel starting from this, and now we are going for the high speed. So somewhere you see here, this was basically designed in the beginning way, and then it is to be executed, you see here, in various ways. So there are, you see the various models, and in these various models, you see here, we can simply go for appropriate in engineering design part, and then we can adopt, you see, the various, we can say design process involving classification of tasks, conceptualization of design, embodiment of the design, and then the detailed design. So, like all these features, whenever we are starting from, like the what exactly our the task is, so we can clearly define our all these tasks, and then accordingly the conceptualization happens. So generally we are, like in the conceptualization design, you might be knowing about that this is mainly on the identification of customer need, then what exactly the problem definition, and in the problem definition, what are exactly the data which we require in terms of material, in terms of space, in terms of all the connecting points. Through that is here the entire, we can say the material or the processes are being flowing. Then in that conceptualization, generally we are going for appropriate selection of these processes to fabricate that. So this is the conceptual design starting from customer need to concept selection, and then we can go for, you see, the embodiment design in which you see the product architecture is there, configurational design is there, parametric designs are there, lots of designs are there. And in the detailed design, we are trying to integrate all those tools through which we are trying to innovate, you see the things right from conceptualization to parametric design and the configuration design. So these are basically various design models are there which we can use, and we can configure those things towards that. So this is all from my side, you see here, in which you see generally we are trying to go for various conceptualization which the working drawings are there. The embodiment design is the assembly and detailed drawings are there. And finally, detailed design is giving us not only about the drawings, but also about to see the processes and the material to fabricate the end design. So this is all you see here, and in that, lots of, we can say, assembly drawings are there, sub-assembly drawings are there, layout drawings are there, installation drawings are there, general assembly drawings are there. So these are all basically the drawing, and then we are trying to analyze various geometry and the dimension in order to fabricate that, and we can finally, like create the bill of material, for which you see here, we can simply show that what exactly the total parts are there as per their dimension. So this is all you see the design thinking and how to iterate those process basically right from the beginning. This was basically the part of that. So this is all from my side, Ranjit ji. Thank you very much for inviting me.
Thank you, sir.
Thank you so much.
Yes, any queries from the participant side? Please ask the questions.
Because you see, like one more thing, when we are trying to design, there is another aspect which is requiring to get in a feasible solution is the failure mode and effect analysis, FMEA, which is very common. Second part is design for reliability, robust design, tolerance. All these are basically very important while designing that. Because we have, since we are doing a common design, so this is the integrated part. But here it has some kind of different part in design thinking to go beyond, you see, this box in which we were doing FMEA, reliability, robust, tolerance, and all that kind of stuff. Somewhere we need to come out from that, and we need to add certain features which might have, you see, some different physically in nature, or conceptualization is altogether different in that case. Anyway, so this is what I was just wanted to add it something. Yeah, I am here open to reply any question, please. ठीक है रंजीत जी,
Any queries, please ask. Yes, Vinit Kumar ji has raised the hand. Yes, Vinit sir, please ask the question.
No, sir. Just I am just clicking some another icon. Thank you, sir. Thank you very much, sir.
Thank you so much.
Sir, thank you for your session. It
Yeah.
was really nice and informative. My only question is that can you please describe the innovation sweet spot with some example, possibly a
Actually,
product?
okay, good. The sweet spot is basically, integration of three things. First is the desirability. So since, like we people are generally going for a desirable solution, that is what our main optimization feature, that this is my desire, and in my empathy, basically, I'm trying to add as much as the customer requirement or the people's need. The first thing comes in this way is the appropriate integration of a feasible solution, because that is mainly building on some kind of strength of the current operational capability. So the first part, you see, once your desirability is fixed, we are basically going towards the feasibility. Even say now we have a feasible solution, but then we need to check crossly about the viability part, a profitable. Say you are designing say right now, you see, we have, you see, the electric vehicle. Now that electrical vehicle is good enough, it is available, we have charge here, but now if I am going to, like some hilly part, will that be a viable solution? No, because once it attains certain kind of gradient, that capability of endorsing yourself towards that path is not enough. So here it is a viability part. So what I mean to say that we need to understand that desirability is one thing, but feasibility and viability, both part must be integrated enough to have a appropriate, sustainable business model. This is the sweet spot of innovation.
Thank you, sir. Thank you very much.
You're welcome.
Sir, one more question asked by the Usha Raghavan.
Uh-huh.
Can a smaller, better solution to an existing design be called design thinking?
Yeah, actually, this extent, like design, the Actually, there is no as such better solution. It is an optimal solution. We can't say this is a better solution. Yeah, at a local problem, if we feel that this is some kind of complexities are there, and if we can avoid that complexity by providing a small, we can say, feasible situation or the solution, that is the best design thinking. Design thinking is not about, we can say, a overall picture about, we can say, big business centric engineering solution. It is basically a customer centric solution. It could be even a small change. You change the bolt, and if provide enough strength, that is also design thinking. That you change the bolt, you adopted, you see some different kind of joining process, maybe we can say welding, or maybe because of anything, that is also a design thinking. So design thinking is not about the overall global solution. It is a customer centric desired solution. All right.
Yes. Yes, sir. Any more questions from the participant side? Okay. I think there is no question, sir. You
Okay.
already
Thank
explained
you.
a lot in the,
Thank you so
in
much.
the lecture, sir. And thank you, sir. We
Thank
are
you.
coming to last session at end of the day.
Okay.
I
Thank you. Allow
sincerely
me to
thank
leave, sir.
Dr. Harsha, sir, for accepting our invitation and giving this innovative talk.
So nice of
Sir,
you.
is more focused on the aspects of design concept with various practical examples. Thank you, sir.
Thank you.
It is very nice presentation, and there is a lot of comments coming in the chat box.
Thank you, sir. Thank you so much, sir.
And I am also thanks for all the participants for joining the session. Dr. Prashanta and Dr. Usha and many more for posting interesting questions and making the session interactive. Thanks a lot.
Okay, sir. Thank you. Have a nice time. Take care.
Sir, participants are asking for the PPTs. I think sir has left the meeting. Then I will ask him for the PPTs. Then I will let you know. And I request all the participants to join at sharp 9:30 a.m. tomorrow for the next session. Thank you all for being
Sorry,
here.
actually, I just click it. Were you saying something to me? Sorry.
Yes, sir.
Sorry,
Sir, participants are asking for the PPTs.
Oh, sir, definitely. I'm going to provide you. I'm going to send you. Effectively today. Sorry, actually, I just clicked it, and then I realized that you were saying something to me.
Yeah, just okay. Okay, sir. Thank you, sir.
Thank you so much. Thank you. Have a nice time. All.
Thank you, sir.
Thank you so much. Bye.